In this chapter, we're going to learn how to summarize and compare distributions. So to start with, let's look at these few learning objectives. The first one, we're going to learn how to organize the data by using these two diagrams. One is called tallies, and another one is called stem and leaf diagrams. And also, we're going to use how to use the stem and leaf diagrams to summarize the data. And then we'll learn two locators of the central value, or to talk about the median, and we'll also introduce the mean. And then we'll discuss how to use the logarithms to examine some very wide-ranging positive values. So to start, let's look at the areas of the 14 counties in the state of Vermont. And we'll use the unit of 10 square miles. And these numbers are 78, 67, 61, 53, 66, 66. And then we have our 8, and then 47, 69, 72, 93, 71, and 78, and 96. So what we want to do is to arrange this data in order to bring out their information and give us some feeling for this data as a whole. But a couple of different ways to do it. One way is to use what we learned that is called the histogram. That will work. Or alternatively, you can also use the cumulative frequency diagram that we learned in the previous chapter. That would also be an excellent tool. Now, today we're going to learn a different method called the tallies. And to do the tallies, first of all, we divide the data into convenient non-overlapping groupings. And this is important, non-overlapping. You want to make sure that those groupings don't have anything in common. For example, you don't want to have one group says from 20 to 30, another group from 30 to 40. That makes sense. However, if you have a number of data that is exactly 30, then you will have a hard time in determining whether this belongs to the first group or the second one. So instead, you can do something like a 20 to 29, or if you have decimal values, 20 to 29.999, and then 30 to 39.99, and so on, to avoid the issue. And then we'll indicate the group frequencies with tally marks. And we can also separate the group measurements from their frequencies, which is through a vertical bar. And this tally will give us some useful information, such as separation, where the data is separated, and also centering, where roughly the center of the data is, and also it also gives us an idea of what the spread looks like. So here, to start with, let's actually go back to the raw data, and at the same time, I'm going to open the whiteboard. So here, let's go to the whiteboard, and then I will do it here. So to start with, let's actually look at this data. We have the area. We have this, look at the area, and also the frequency. Well, the area, we can divide it into groups such as from 0 to 9. And notice that there's no decimal, so we just choose the integer values, and then from 10 to 19, and 20 to 29, 30 to 39, and 40 to 49, and 50 to 59, and then 60 to 69, and 70 to 79, and 80 to 89. Notice the largest area is actually 96. So you do need a 90 to 99, and that's it. No need to go beyond that. And now let's go through this data one at a time. So I'm going to use a different color. You don't have to do that. So here, the first one is 78. So that belongs to this group 70, 79. So I'm going to mark is with tally mark 7 to 78. And then 67, that's right here. And then 61, that's another one in this group. And 53. And then 66, another 66. And then 8, that's the first group. And then 47 right here. And then 69, when it keeps 5, usually we just draw our line like this to indicate this is a 5. And then 72, and 93, 71, and 78, and 96. As you see here, we can look at these completed tallies and get a lot of useful information. For example, the separation, we can see it obviously separates into 3 groups. One that's very small, and one most of them are medium size, 2 are very large. And also we can look at the centering. You see the center is around 60-ish. And then also we can look at the spread. That is somewhere between 1 digits to 90 something. Of course, we don't know the exact value of spread, but this will give us a good idea of what the spread would be. Well, this method is excellent, but at the same time, we also will inevitably lose some information because, for example, if you look at this one, there is 1 in the group 40 to 49. But is this measurement 40 or 41 or 45 or 49? The answer is we don't know. This information is simply lost. We can't recover it by just looking at these tallies. So this can be sometimes a disadvantage. That's why we need a different method. That's the second method when you introduce. That's called stem and leaf diagrams. And by the way, for the previous one, let me just remember to draw our vertical line for separation purposes. And this is the vertical line that I'm going to draw right here. All right, now the second method is called stem and leaf diagrams. So instead of using group intervals, we'll just use the 10 digits. We'll use the 10 digits. And then we'll place the right-hand side of the vertical bar in this unit digits opposite to this list of 10 digits. Basically, we just put 1 digit next to it. And we can also arrange the units or digits to the right in ascending order if necessary. We may do that. It is not required, but in a lot of cases, it makes this diagram look better. So this is the stem and leaf diagram. And here in this stem and leaf diagram, and I'm going to show you what it looks like. So here we're going to move this around, and then we'll use the 0th digit. And then we're going to use the numbers such as 0, this is the 10th digit, and then 1, 2, 3, and 4, and 5, 6, 7, 8, 9, and then we use the 1st digit. And so you're going to draw a vertical bar like this, and then you're going to put 1st digit to the right. For example, let's go back to the raw data, and you see here the first one is 78. So instead of putting 1 tally, you're going to put an 8 here, indicating this number is 78. And there you have 67, 61, and 53, 66, 66, and then there is number 8, so 08. And there is a 47, 69, and 72, 93, and 71, 78, and 96. Well, do you need to reorder these numbers? The answer is up to you. It's optional. You don't have to do it, but if you want to do it to make it look better, you're definitely welcome to do it. So here for the stem and leaf diagrams, and notice that each row is called a stem. So the stems would be something like this row, and this row, etc. Those are not only rows apparently. So all the rows are called the stems. And then the numbers on the left of the vertical bar are called the stem ends. So the stem ends refers to those numbers, and so on. Of course, this doesn't end here. And then what we mean by the leaves would be the numbers on the right of the bar. So here are the leaves that include this number, those numbers, and so on. So again, those are the standard terminologies. And I believe this is coming from depicting a tree. When you have a tree, you have some stems, and each stem you have some leaves. Each stem also has a stem end. So you see here in this stem, if you compare these two methods, you notice that one obvious advantage for this stem and leaf diagram is that no information is lost. For example, you have 40 something, now you know exactly it is 47. Here is exactly 53, and so on. So we didn't really lose the information. And so this is the second method. And now the next example, you can also do a cost of electrical insulation. And these numbers you see here, the range, and you have 50s, 40s, and 30s, and so on. So you have a wide range of data. And well, for this one, I would encourage you to practice the stem and leaf diagram. And this example is actually from page 30 to 31 from the book. And what we can do with this example is to draw some stem and leaf diagram like this. I'll show you. Show just a minute how this works. Yeah, right here. So you can do some stems like you can do stems like we'll use the integer values such as 33, and by the way, 33 is the smallest one, like 34, 35, 36, and 37, and so on. I'm not going to finish it, and then I would encourage you to try it, and then eventually you can put each of the decimals in somewhere here. Of course, this M doesn't end here. The largest one, there is a 57.5 somewhere, so you need to go all the way up to 57. And then this will be the way that you do it. I'm not going to do it in this video, but you're welcome to try it by yourself. Now, sometimes when we have a data of large range, we may also need to indicate actual digits with actual vertical lines. For example, you have some data ranging from 10 to 10,000, and then we'll do something like this. So for example, when the actual number is 4, you can just write as 4 with one line followed by 0. So one line means this data point is in the scale of 1, so it's 4. And then we have 40, the actual number is 40, and then we'll write 4 followed by 2 lines, and then with a 0. With 400, we'll use 4 followed by 3 lines and 0. How about something like 445? Well, we use 4, it's still in the hundreds, 400, so we use 4 followed by 3 lines, and then we'll write the next number after 4, which is still 4. And you may say, hey, how about the 5? The answer is we don't worry about it. We don't run it up, and we simply ignore it. And so it's kind of like when we're looking at the price of some product. Let's say you know it's $445. That's very precise, but if you know it's 440-ish, that's probably good enough for some approximation purposes. So again, we'll lose a little bit of information, but as long as keep the first 2 digits, you're not really losing much. And again, if you have 679, you simply write a 6 followed by 3 lines and then a 7. This means it's in 670s. And now, in the next example, we're going to look at some words for projects in Tennessee, where the actual numbers can range from like tens of thousands to millions. So in this case, we'll use the one vertical line to mean tens of thousands. So here, if you have 12,165, we're going to write as one vertical bar followed by 2. And then you have 70,602. This is again in tens of thousands. We'll use 7 followed by 1 vertical line followed by 0. And then you have 167,170. This is in the hundreds of thousands. I believe the one English word for that is called a lakh, L-A-K-H. And we simply write as one lakh, and then 2 vertical lines followed by 6. And the next one, similarly, 4, 2 vertical lines followed by 2. We do have 2 numbers that are in their millions, 1.2 million something. We just write 1 followed by 3 vertical lines followed by 2. And also there is a 2.2 million, 3 vertical lines followed by 2 as well. So here, once you have learned that, I would encourage you to take a look at page 36. And there's an example. This is the full list of the award of projects in Tennessee. And make sure you read it and don't look at the column called logarithm yet. Just look at the dollar amount and then construct a stem and leaf diagram by yourself. So I'm going to give you a little bit hint to get you started. So notice that those numbers are in their tens of thousands and hundreds of thousands and millions. What we're going to do is to write numbers such as 1 and then 2, 3, 4, 5, 6, 7, 8, 9. Those will be the tens of thousands, and then hundreds of thousands will be 1. I mean, it will be 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you have millions. You have 1 million, 2 million. That's it. There's no 3 millions. So here, this part will be tens of thousands. And then this part will be hundreds of thousands. And then this will be millions. That'll be these two. All right, so for the tens of thousands, we're going to draw one vertical bar. And for the hundreds of thousands, two vertical bars. For the millions, three. So what you can do to accomplish this is to draw one long vertical bar all the way down. And then another vertical bar from the hundreds of thousands to the millions. And I'm sorry, this is not vertical. And I don't mean to do that. Okay. And then one vertical bar just for the millions. So now you can put the numbers on the right. For example, if you have tens of thousands, like 12,165, simply put a 1, 2 here. And the next one, 70, just put a 70 here. And then you have 167,000-ish. So it's 167. So it's put 1 followed by 6 right here. This vertical bar needs a little bit longer. And then you have 428,000, so it's 4 followed by 2, and 1.2 million, and 2.2 million, etc. So I would encourage you to finish this exercise at home. And finally, let's introduce how these things can be done by R. Of course, to do it by R, you need to firstly define your data, and sometimes unfortunately, you have to type in all the data points. Or if this data was stored in their, let's say in the spreadsheet, in their Microsoft Excel worksheet, and then there's a way to import it, but that's beyond the scope of this course. But for now, let's say you define this as X. So if you quote X, this is the data point, and